Well, if you look at the periodic table, chlorine, for example, has these two numbers. The top number, the big number, is the mass number. Now, it might not always be on the top, but the bigger number is always the mass number, and that's the number of protons and neutrons. So how comes that isn't an integer? Well, on the periodic table, it's a weighted average. And so if we were going to ask you how many protons, neutrons, and electrons, we'd have to give you the integer number of a specific isotope of the atom. The atomic number, that's the small number. That's the number of protons, and that's the same as the number of electrons if you're talking about an atom. And we'll see ions a little bit later. The small number is the number of electrons in an atom. The small number is the number of protons in an atom. And the difference between the number, well, that's the number of neutrons. In this case, 18. So that was a simple example. Slightly more difficult. Electrons, protons, and neutrons, what occurs in the same amount? Small number is the electrons, and small number is the protons for atoms. And the difference is the neutrons. Okay. Small number is the electrons, small number is the protons. No, that's wrong. That's not an atom. That's an ion. See, it has a charge, S2-. That 2- means that two electrons, two negative electrons, all electrons are negative, have been added. So you have to include that in the number of electrons. The small number is always going to be the protons, though. And the difference is always going to be the number of neutrons. So the electrons could change. But the protons are always a small number, and the difference is always the neutrons. And finally, silicon-28 atom can theoretically become stable by gaining or losing 4 electrons. Let's fill in the table. So E, P, and N for electrons, protons, and neutrons. So the smaller number, the atomic number, is always the number of protons. And the difference in the numbers is always the number of neutrons for atoms or for ions. Now, if it's an atom, it has a neutral charge, so no charge is written, which means the number of electrons equals the number of protons to give it a neutral charge. Now that's 4-, it's gained 4 electrons, 4 negative electrons, so the charge is now 4-. But for 4+, you might think, oh, it's gained 4 protons. No. If you gain protons, you've changed the element. It won't be silicon anymore. And you can't gain protons in chemistry. In chemistry, we just mess about with the electrons. So we've lost 4 negative electrons. Now, losing negative makes something positive.